Hello everyone, welcome to my presentation of Ethernet framing. As we know, when two computers connect together with the Ethernet, then they will sending data to and forward between them. And the format of the data should following some rules. Okay, this rule is defined by IEEE. Okay, also is known as the IEEE 802 standard. Okay, in this chapter, we will explain the reference models of the network. Okay, there are many different reference models, and we discuss some of them. And then we will discuss the Ethernet frame, the format of the Ethernet frame, and then explain the MAC addressing, the layer 2 address in the reference model, and then how the Ethernet use the media to access the media, to share the media between different computers. Okay, and then first about the reference models. As we know, there are different network reference models. Okay, first, this is a TCP/IP. Yeah, TCP/IP is itself, it's a protocol suite, but it's also the reference models. And another is the well-known OSI reference models. Okay, and other companies, okay, also developed some other protocols, such as the Novell company developed IPX and SPX. Okay, this protocol, sometimes I think about 20 years ago, is used widely in our LAN network. Okay, and IBM also developed a network architecture we called CCNA. Okay, and all these reference models usually is defined as the upper layer protocols. Okay, and the physical layer, the bottom layer is usually use the same. Okay, nowadays the standard for the physical layers, for the bottom layers, there's two types, LANs and the WANs. LAN means the local area network. The WAN means the wide area network. The LANs is a network located to a narrow area, okay, in the campus. Okay, in the wide area usually can extend to a long distance, about some kilometers to thousands of kilometers far away. Okay, and the LAN standard usually is specified by the IEEE. Okay, IEEE. These organizations. Of course, under the IEEE, there's an office we called 802. They specify the many standards about the LANs. Okay, and the WANs, nowadays, we usually use Ethernet. Of course, Ethernet is also the LAN standard. And nowadays, Ethernet also has the WAN standard. Okay, and the PVP and the HDLC nowadays are also used for the WAN connections. Okay. Then, first, we refer to the TCP/IP reference model. Okay, the TCP/IP protocol nowadays is most widely used in our network. And the TCP/IP reference model is divided network into four layers. On the upper layer at the top is the application layer. The application layer just the presentation of the applications, such as the pictures, the videos, the voice that interact with the people. Okay, and then the TCP/IP protocol. Yeah, it's in the transport layer and the network layer. The transport layer is to confirm the communication between two hosts is reliable. That means no packet will be dropped. And if the packet is lost when transmitting, then the transport layer will compensate, will repair it. Okay, this is the transport layer. Of course, the transport layer is the well-known protocol is the TCP. Okay, the TCP. Okay, and then the network layer. The network layer, the protocol is IP. The network layer is to deal with the path selection. That means the communication is between two computers, but between these two computers, there's a network. So the packet should follow certain path and then reach to the destination. Okay. So the IP layer, the network layer, IP protocol just deal with this. Which path should be chosen? Okay. And then the Ethernet. This is the network interface layer. This network interface layer just how deal with how the IP protocols to use the physical medias. Between each two device, the computer, the host to the router, and the router between router and the two router, and then there's a physical media. Then how to use this media, how to modulate the signals, and then send it to by the physical media to reach the next hop. Okay, this is the function of the network interface layer. Okay, this is the TCP/IP layered model. And the most detailed model also is the most widely known reference model is the ISO, the International Standard Organization's OSI model. Okay, the OSI means Open System Interconnection. Okay, that's the model divides the network function into 7 layers, 1, 2, 7, 1, 2, 3, and then the 7. Okay, 7 layers. And this reference model divides the function in between different layers. Okay, first we can see the physical layer. In the physical layer, just the physical device, the lines, the medias, the network interface card, and these hardwares and the connectors and so on. Okay, this is the physical layer. And then the signals sending on the physical layer, it's the bit stream. Okay, bit stream. It just deal with the signals. Okay, deal with signals, the voltage levels, and so on. Okay, and the second layer is the data link layer. Then data link layer. In the data link layer, there's begin to have the structure of the data. The data have structures. This data we called RAM. And then in this layer, the frame have the address to choose the destination. Okay, and of course also develop a media, how to use the media, developed a mechanism how to use the media. Okay, and then the third level is the network layer. The network layer, in the network layer, the data we called packet. In this layer, just deal with the path selection. Okay, use addressing and routing. Yeah, just choose the route, the best path to the destination. Okay, then transport layer. The transport layer, the data sending in the transport layer, we call the segment. Okay, segment. And then in this layer, just to confirm the transmission of the data is reliable. That means no packet is lost. Okay, if there's a packet dropped between the two communication devices, then this transport layer will resend the packet. Okay, and then the session layer to manage the sessions. Okay, each communication, not only one packet. Okay, there's many packets. This many packet just form the one session. Okay, and then the presentation layer. The presentation layer just to coding. The coding encryption or decryption and the data formatting. That means, for example, what's our see in the computer? That's a picture, that's a video, but in the computer's storage or the sending of the data, it's not a picture, it's the data. Okay, it's the data. So the picture, usually we know the pictures format such as the JPG, okay, JPG, and such as the BMP, JPG, okay. Okay, that's the format of the data. Okay, this is the function of the presentation layer. Okay, of course, what we see is the picture, and then in the computer, it's the data. Okay, and then the application layer. Application layer just to show the results. Okay, just to show the results. Okay, and this is the 7 layers, each layer's function. Okay, and of course, the OSI model is most widely known, and there's some relationship between OSI model and the TCP/IP model. In the TCP/IP model, there are 4 layers. So this 3 layer in the TCP/IP model, it's application layer, and then the transport layer, and this is the TCP, and this is IP, the network layer, and then at the bottom 2 layer is the network interface layer. Okay. This is the OSI layered model. Okay, here is the encapsulation of the data. Okay, that means what we see, for example, we processing the data from the 7 layer to the layer 1. Okay, the people just using the data at the 7 layer to see the picture, to see the video, and then this is the data. And then when the data want to sending to the other side, that's to the another computers, then the data first should be coding to a data that can be sent. Okay, and then in the session layer, for my session, all this layer, the data is the same. Okay, the data, and then the transport layer, yeah, this is the segment. On this 3 upper layer, it's all data. And then on the transport layer to form the segments. Okay, in the segment, the computer will adding a header. This header, of course, have the function that to confirm that no packet. Of course, when the data is sending, not only one packet, there's a series of packets, many packets. So you should make sure that no packet is lost. Okay, in the header, there's a serial number and so on. Okay, this is a segment. And then the network layer. The network layer is a packet. We'll choose the best path to the destination. Okay, so the destination should be identified on this header. Okay, that's a network also as a header. And on this network header, there contain the destination's address and the source address and so on. So there's IP address on this header. Okay, and then this packet should be sending to the media. Okay, so the network interface layer, the data link layer, should still adding another header and a trailer. The trailer used to frame check, to check if there's some error happened when sending between two devices. And this header also to decide the destination, who should receive this frame. Okay, and then the physical layer just change the data into the signals, the voltage, the high level or the low level voltage. Okay, this is the encapsulation process. Of course, when the data reaching the receiver, then the receiver gets the signals and then first sending to the second layer. Okay, the second layer first check if the data there are some errors. If there's no errors, then decide who should receive. If it's me, I should receive, then received it, and then this too is stripped, and then sending to the upper layer. And then using the destination IP address to decide if I should receive, then receive, and then sending to transport layer. Okay, then step by step sending to the upper layer, and then show the user, okay, the appearance, for example, the pictures. Okay.